Today we're going to be building the Electric Handy Drill. Okay, so we're going to be unboxing the Electric Handy Drill, so let's first get into this box. We'll do a deep dive. We're going to build this from scratch. So on the outside of the box, we see a beautiful picture of the Electric Handy Drill. We see the internals of this wonderful tool. And on the sides of the box, we have some information here on what exactly this tool is used for. So if you take a look at what it's used for here, it looks like you're able to drill holes in wood using this tool. Now, I will tell you that this is not an all-metal construction. It's plastic. This whole thing here is plastic, just like the router is plastic on the outside and with the metal parts basically jutting out from the insides. So that's what you're getting here, and it looks almost identical except for the color and the tool piece that you use at the very outside where the collet is. So we have here the parts of the Electric Handy Drill. It says collet chuck, that's this part here. We have here the 40T gear inside, the 10T to 40T gear, 10T to 36T gear. We also have a motor inside, and I'll show you the motor because it's very similar, if not the same, as the Electric Handy router motor. It looks like a box stock motor, but it has two holes in it. I'll show you it soon. Trigger guard. So the trigger guard you can't see here, but on here you can see the trigger guard. It's a lock to prevent you from accessing this. So if you turn it this way, you're no longer able to activate this router. But if you turn it to unlock mode, you could use it. So there's a trigger switch, that's this gray. Switch lock, that's inside. Battery is not included inside this compartment here. And that's it. So you're supposed to be getting a number of drill pieces, drill bits with this as well. So let's take a look at the outside of the box. Item number 74041, the Electric Handy Drill by Tamiya. On this side here, it shows you that you could drill holes in wood or in plastics. And it says you should wear safety goggles here. And here is the basic drill set, which is not included. So I'm curious to see what drill bits are actually included in this kit. So it says here, copyright 1999 to 2003 Tamiya, made in Japan. So there you go. And on this side, nothing else. And this side, don't know what it says, but you can look it up via Google Translate to see exactly what this says. So let's open up the box and see what's inside. So here, let me move my mouse out of the way. We have here plastic parts that we're going to be cutting off the trees. We also have more plastic parts, the gray pieces. And we also have the pack that includes the motor. Now take a look at the motor here. It's got the two aspirated holes right there. So it looks like a box stock motor, but it's got these two holes right here. And I presume that by adding these two holes to this box stock motor, or whatever motor it is, the aspiration effect probably allows this motor to behave in ways that a normal box stock car kit motor does not allow. So I assume that you're getting better torque and better speed with these holes, this aspiration on the motor. So there you go. Because I'm willing to bet that if you swapped this out with a more powerful motor than a box stock motor, let's say you swapped it to a box stock motor from a car kit, you're probably not going to get the same torque as this motor here. If you tried switching it to a tune class motor, you might get the same torque as what you see here, maybe more. Maybe you'll get something greater than that. I'm not sure. So yeah, that's one thing to try in the very near future, to see if punching holes in your motor can actually increase the speed of your car, of your motor and your car. But remember, that's not allowed. That's basically technically not allowed. You should not be punching holes in any motor that you're using to race a car with. But here, it's just interesting to see that these holes are here in this kit, as well as the Electric Handy router kit. So, and like I said, these are kits, so you actually have to build this drill to be able to use it. So it's a fun little kit, and the last time it took about 45 minutes to an hour to build the router. You'll spend about that much time here on this one as well. So we're going to be building this step by step, and you'll see that it basically starts off like a car kit. So car kit, let's see, instructions step 1. Now inside the box, ooh, this picture here, this is what the end product is supposed to look like. And this Electric Handy, oh no, I'm sorry, this is the Electric Handy router, their sister product, the one that I just showed you here. So I thought this was actually a picture of the end product of this drill, this handy drill. But no, this is the router. and they are both part of the Tamiya Craft Tools. Let's remove all the pieces from the packaging. Now you get the familiar grease tube. We're not going to be using this, so I'm going to be setting this aside. We'll be using the Tamiya F-grease instead. The collet chuck, battery contacts, the spring thing, which is, what is it, the switch lock mechanism? I think I see a drill bit there. Yes, I do. So let's open that and set that aside too. So I think what I showed you before was the collet, and this might be the collet chuck here. So put this over here. We've got a pack of screws. Put them right here. And then we just have the plastic parts. So the plastic parts, this is the B part set, and I believe these are all ABS plastic. Yes, they are. And here we have the A parts, also made of ABS plastic. The gears, these are the C parts. C parts should also be ABS plastic. And the sticker that says Electric Handy Drill on it, which I don't think I put on my router, the sticker there, so I'm probably going to omit it here as well. But in case you have people who are taking a look at these two tools simultaneously, it's probably best to try to distinguish them in some way, and this sticker will help you distinguish them. But those of you who are in the know that the blue one is the Electric Handy Drill. Now, let's cut these parts from the trees. So here, I'm always a little hesitant on cutting parts like this off, because it seems to me that if I just cut them off together like this, then that might cause a problem. Let's see. Nope, looks like it's good. Good. Okay. So we've got a gear here. Whoop. See those little pieces that you have to trim off at the end. They're just sticking out there. I don't like them. Gears on a tree is always iffy to me. So I'm sure that with continued use of this drill, these gears are likely to smooth out over time. So you basically have to use this product a lot in the initial break-in period. There we go. There we go. Maybe we'll finish it off with a God Hand. God Hand nippers, the best. Great for Gundam or mini four-wheel drive. You're supposed to do it sideways like this. So how well the God Hand works for you is really dependent on the user, not the tool itself. So just because you're using it so-called the right way doesn't mean that you'll get the best results. You just have to keep practicing your side cutting abilities. There we go, that's smooth. Cool. It's good. Good enough. And you can be a perfectionist with these. These are like surgical compared to the Tamiya ones. The Tamiya is like good for raw cuts, and this is the finisher. This one's a little more challenging, getting it around the curve right there. So I'm just going to give a raw cut here like this, and then I'll finish it off with the God Hand. Get a raw cut. This one's about to just fall off, so quick cut there. raw cut, raw cut, normal cut. So basically, if you've got like a flat surface where the tree's extending out, then you can give it the full cut that it deserves. But really, the God hand is going to finish this off totally. And like I said, you try to cut it sideways like this. You're trying to lay the flat part of the God hand against the flat part of the surface. Now, if there's no flat surface, then of course this is not going to work as optimally as you'd like. There we go. Slices like butter. Plastic feels like butter in the hands of God hand. Now this one's much harder. This one you have to kind of angle it a certain way. So it's not going to be totally exact. So you're going to do two cuts, maybe like, let's rest it there. Give it one. And that might be enough. A little more. There we go. Maybe another one. And one more maybe. There. Took off a little too much. So don't worry about that. You can always file it with a file, and I like to use a nail file with a very fine grit. But the better thing to use is God hand sponges. Yes. So these are good for Gundam things or Tamiya things. And with this sponge set here, I think I have a whole bunch already. Yes, here they are. Take these out here. And really, do you have to be really, really super precise? No, no. You could simply leave it as is, but if you want to be super precise, you want to use this product here. So here's a 400, this is a 120. Let's kind of lay them out right above here so that we can access them easily. 10,000, this is the one that we end with. 2,000, 8,000, 4,000. You're not going to be using every single one of these. You're just going to first start off with a coarse filing, and then you get a little more precise after that. So let's try to get this one off using, the God hand. And there's a way to use the God hand too. It's like you brace with your thumb on here, and then you take the grip and you squeeze, but you're actually pulling inward with just your fingers. I think that's the way to do it. And there we go. Then it slices through like butter. Try again to try to get rid of more of the plastic. I tend to like to turn at an angle like this. Now this looks a little rough, but we'll fix it up using the sanding blocks. There we go. Okay, so let's start off with a 400 grit, and we're going to be doing a rough, coarse sanding here, just getting rid of, yes, a lot of that stuff there. It's just, yeah, let's get rid of that. And it's going to rough up stuff, as you see here. It's no longer going to be smooth and shiny, but don't worry about that. We have 10,000 grit to make it smooth and shiny. So you don't want to rush it right away. You want to start off with 400, and then you want to go up incrementally, little by little, until it gets smooth. So you'll still see this funny burr over here in some cases. And some people are okay with that, others are not. It's how you're going to sand this down to your liking. So just keep that in mind. It might not be perfect, but we're going to try to make it as perfect as possible. So here we go. Using the 400 to sand down roughly. Yes. Good. And then we move on to, let's say, 1,000. Okay. Good. Then we move on to 4,000. So I could have used 2,000, right? You can, but you don't have to. You can skip. Then we move on to 8,000. Make sure you brace the plastic. You don't want to crack it. You don't want to accidentally break it in your hands. And now 10,000, the final polish. And with this, you should get a smooth, shiny surface again. It might not be as shiny and smooth as the original, but it's pretty close. So now it's smooth here and smooth here, and it's going to be looking quite nice, except you might see that little thing right there and get kind of bugged out by it, that little bump. But really, it's not going to affect the function of this tool. It's going to affect the beauty of the tool, that's true, but not the function of the tool. But here, it's smooth, there's not going to be any rough burrs sticking out, so you won't like scratch yourself. That's what we're going for. And here we do the same thing. So here, let's use the God hand to snip off this. Good. And use my angle technique. Okay. And snip off this. We're doing 2 shots here. Okay, good. 400. So there is a chance that you might get a little overzealous with sanding. And so you want to try to not be overzealous when you're sanding. You want to try to just get rid of the burr and not much else. But if you do happen to shave off more, you just have to be mindful of not shaving off more. And every now and again you can try to align the parts together and see how far you're at. So you don't want to sand too overzealously on one piece and then not enough on the other piece. You want to try to sand equally on both pieces for best results. So because I'm not using the other ones, I think I'm going to just shift them out of the way. There. So we have a 400, 1,000, 4,000, 8,000, and 10,000 that we're using. Good. Okay, now 8,000. Now 10,000. To restore the shininess, the luster. And this is an optional step. You don't really have to do this. It's just if you're trying to get this to look nice as possible. And then placing the pieces together. There, you definitely see the burr there. But that's okay, because it's not going to affect the function of this. The beauty of it, yeah, you can get a little closer with the sanding. You can try to knock out the burr as much as you want, but in the end, this is pretty good. So I'm happy with it. Let's take a look at this piece here. I think we got real close here on this. And if I was like super anal retentive, which I am, then we'll just knock out that burr right there. The other one is pretty good. It's pretty smooth. Okay, 1,000. Okay, 4,000. Okay, 8,000. And 10,000. When you get to the 8,000, it starts feeling like you're polishing something rather than sanding it. Nice. Okay, great. We're done with that. Now the gray parts. Gray parts. For things like this, I use the Tamiya nippers. Good. We're doing some good cuts so far. So maybe a big question for many of you might be, what happens if I accidentally clip the wrong thing on the tree and like I clip off something more than I should have? Will Tamiya like replace the part for me? I'm sure they have some sort of a service where you can get a spare part for your kit that you potentially accidentally damaged. It'll cost some money to do this, to get that part, but I'm sure they can do that. You just have to contact your local, in your country, that is, Tamiya representative, and hopefully they'll be able to get you the part for some amount of money. So there we go, all of the B parts. Okay, now we just have the parts, so now we're going to put everything together. So, first step in our instructions is to assemble the battery terminal. So, we didn't even cut that part out of the package yet, so let's do that. Okay, here we go. All the parts are out of their bags and off of the tree. So, first things first, the battery terminal. So this is basically exactly like how you would assemble any Tamiya car kit or electric craft tool. So here it is. Just snap this in place, but I want to make sure that it's exactly there. There you go. You heard that snap, right? It's nice. Okay, so this is done according to these instructions. This is done. Here, snap, snap, and it's done. Instruction 2. It says here, attaching the motor. So those of you who know me and Tamiya motors, I usually break them in using a special water tuning process for box stock. You don't have to do that here, because over time this drill is just going to kind of like break itself in. So here it says you just simply place this on here, like so, and push this in place. So let's do that. There you go, it's flush. The shaft itself is flush with the end of this gear, this little pinion gear. So that's it. And then you attach the motor to this battery terminal. So here, let's bend this up a little bit. The terminals on the motor are different than your typical box stock motor terminals. And I'll show you the difference between that and a typical box stock motor. So here, box stock motor looks like copper terminals. Here, on this electric handy router, it looks like it's, get all this stuff off. It looks like it is gold plated. So maybe there's a difference there. I'm not sure. It's an SMC motor versus a Mabuchi motor. Mabuchi motors don't have these holes here. So this is like creating a little bit of aspiration here. So you would think to yourself, maybe this is a superior motor. Not this, but motors that have these two holes on them, like this, the SMC motors, are superior to the Mabuchi motors, but a lot of people feel that that's not the case. A lot of people feel that Mabuchi motors are superior to SMC motors. But really, they're almost like they're for different purposes. One is more for speed and one is more for torque. If I would venture to guess, I would say that the SMC is more for speed, like almost like a rev tune motor, and the Mabuchi is more like for torque, which is more like a torque tuned motor. Okay, so we have here part 2, section 2 that is, of these instructions have been completed. Now it says attaching the trigger. Okay, so now we're getting more into a deep dive of what's going on here with instruction 3. So instruction 3 has, okay, so first it says make sure you screw this thing in thoroughly. Screws should be screwed in thoroughly. So let's take a look at all of these parts that we need here. We need this. Set the other parts aside. In fact, we can move all these sanding blocks away from our work area for now, or maybe forever, because we're done with them. Okay, so let me move some more things out of the way so you can all see. Okay, so here we have this, and we want to place this part here, it looks like. There we go, matches with that. We want to place Where's that spring thing? There it is. The spring thing has a little hook on the end of it. Here's the hook, here on this end right here. So we're putting that down into the hole here. So let's put this into here first. So, okay. What is this part? No. The trigger, that's what we need. The trigger goes here. Come on, trigger. There you go. Trigger goes here like this. Okay, and then this part here, what else do we need? We need a bushing. Okay, so the bushing goes here. It goes through this part here. Yes, so this bushing goes through here, and then we need this B3 piece. So B2 and B3 connected like this, and we need to place all of these things in there. Now, they say to use some of this grease on there, so let me take out the grease from my toolkit. The F grease is what I'm going to use. It's much more convenient to use the F grease than it is to use the other one that comes with the kit. So here we go, a little bit of this all around. Good. Place this here, like so. And what else? We need some grease inside here. Okay. I'll put this in here, like so. Come on, there we go. Good. Okay, that's in there. That's in there. We need grease here. Okay, that's in there. And we need to put this where here, and this here, and okay. I think it all goes like this. There we go. Yes. And what else? The spring thing that goes down. So that little hook goes into here. Okay. Goes into there, but there's also, what else? There's this part, the washer. Or is it a small washer? 2mm washer, that's this one, the smaller one. And that goes into, so you're closing up this whole part here with this screw. This screw's a 2mm. So they make these to scale, so you can simply measure which of these screws this belongs to. So it is not this one, but this one. I believe, yes. This one's too short. This one's long enough. So it's this one. And this goes through the washer. And through this part here, and through that bushing. Is that right? Let's see. And this hook. The hook actually goes in through here. There we go. I think that's it, right? Is that right? So I need to just screw this in place, but what about this thing? This is sticking up a little bit. Not liking that. Is it supposed to be like this? Oh, there we go. Oop, that's not fitting in there. Why is it not fitting in? Oh, there it goes. It goes up here. It goes up here. There we go. Okay. Okay, there. Pretty cool. All right, what else do we need to grease up just in case? No, we need that there, that there. So I think we're done with this part here. This whole part here. Now we'll do this part here. Or is it a continuation of that? Should I have done this one first or this one? Is it right to left or left to right? I mean, here we have this going, in the first instruction, we have things going from left to right. So here, left to right, you don't go this way, you go this way. So here, I'm assuming we're going left to right, and they're just showing you the next steps, irrespective of this whole stuff already being installed. So let's try that. Let's find that piece that we need. It's this funky looking piece right here, and keep losing it, hold on. Keep losing this piece. It's this piece right here, and it has to be in up position, and we want to place it right there. And we need also a screw, a little screw. This is the 2x8mm screw. Is that this guy, or is it this guy? Let's see. I think it's this guy right here. Yes, it is. So we need to take this, and we need to basically attach it through here, and it goes through there, I think. Okay, on the other side, there's that other piece. So the other piece is this piece here, I believe. B6. If I hold this down, hold this here like so, yes. Lock and unlock. Okay. Let's just tighten it some more. Hope I didn't strip it. Okay, so this is the lock. And when I turn it this way, then it's unlocked. Okay, very simple mechanism. Took a while to get in. Okay, here, shaft stopper. That looks like this. Good. Spring. The spring looks bigger in the picture than it really is. It says coil spring. There's only one, so we put that in there. Good. And then this funky piece here, B7. And we put this right on top, and we screw it in with the screws, I believe. Or do we just press this in? Let's see. Come on. Center, center, center. How about we do this? Come on, smarty pants. Come on, 3 master's degrees. I like to poke fun of myself a lot. Just because you have 3 master's degrees does not mean that you have practical knowledge all the time. Still, it means we're pretty darn smart. So I can kind of figure out most things. Okay, cool. I think you just push it in, and it seems a little weird. Yeah, there we go. Push it in some more. So I'm going to take this, push it in, take this, push it in. Cool. There you go. Bloop, bloop, bloop. So, I think that's it. So they show you here, trigger locked and trigger unlocked. I just showed you that. This part is all complete. We are done with section 3. Section 4 is a big one too. So we have here, remove flash. Okay, we did that. So C1, which is C1? This looks like C1. Okay, which is C3? One of these looks like C3. I think it's this one. Which is C2? It's the one that has the longer one. This is C2. Okay, great. So C1, it's this one, and we're looking at flipping it this way because this is the longer, well wait, I believe this is the longer way. This goes this way. And then we need this part here. It's got 4 pegs on this side, 2 pegs on this side. So it's on the 4 side one. Do it this way, or is it this way? Let's see. This doesn't slot in here, so it goes in this way. We need to place this long piece here, through here, and through here. There we go. Like so. So plastic bearing. We need to grease up this part here. This picture shows this with this. Oh wait, they want you to go here. Okay, so this with, this, and then the 3mm washer. This goes with C5, which is this part, and then that goes with this, or does it? Something goes into here. Aha, the stick. The stick goes into here, which then goes into here, pokes into here. Then we've got the cap that goes onto the whole thing. Oop, the short one. Duh. Look at the pictures. There we go. And the cap goes on top. Da da da. I think that's it. So this goes to this. This goes down here. This goes here. We got the 3mm washer, C5. We got C3. We got C4. And then what? We want to put the whole funky thing in place there. So now we go down here. This whole funky thing goes in just like that. Oh wait, we forgot something. We forgot to grease up this rod. Yes. And they also want you to grease up this part too, so let's do that. Good. Okay, now we can put this in there. And what is it? It should slot in place right there. I think I made this more complicated than it should have been, right? So then we need to place this in here. We need to grease this up and insert this in place. Sometimes when we overthink things, we tend to make things seem a lot more complicated than they really are. So, yeah. There we go. Goes in just like that. Actually, so this is the big problem with Tamiya instructions. They're all in black and white. Someone who's not visually oriented won't be able to see the colors very easily here, like the colors. Like this is supposed to be this right here, but it would have been like so much more helpful if they just printed this in color rather than in black and white. So that's the big problem there. So it says here that they want you to spread a thin layer of grease on the teeth of each gear. So we're going to be doing that. So here we go. Let's do it. Good. Okay, now we're on to the next section, section 5. Section 5 says attach switch terminals. Okay, so let's take a look at that. Let's fold it like this so we just see section 5. Nothing else but section 5. So here, switch terminals. And here, just like the cars. Now, next section is here. We want to place this. Good. Onto here. Oop, the motor. Silly. Let's put some grease on here too. Okay, so now we're going to put the screws in place. Oh wait, we forgot something. The collet. You want to have the collet lock, right, on there, because if you don't, the whole thing's going to fall apart badly. Like, really badly. Yes, so before we did any of this stuff, we needed to put this in place. There we go. This holds it in place. Makes a lot more sense now. Okay. Now we got something. Cool. Good. Now we can seal it up. Now, those of you who've seen the build of the Electric Handy router, you know that if you don't get the screws in place a certain way, then there's going to be like a crack on the top. Not a crack, but it's going to be more open in the top than you want it to be. You want this to be flush as possible. So you will need to make sure that all of the screws are exactly in place and tight for that to happen. So let's do that. Because they really needed an additional screw somewhere here, but they didn't design this the way that it should, or they should have used metal parts instead of plastic. For tools, you really need to use metal, not plastic. Here we go, the split that I'm talking about. So you really need to drive this screw in there. And really, you need something bigger than this to screw this in place. There we go. There's a little gap there, I don't like it. Okay, that's the best that can be done at this point. And let's put batteries in this and see how we fare. So the batteries go in this way. And here's another one. Cool. And where's the cover? The cover is somewhere here. Yes. There you have it. You get one drill bit, guys. It's probably a 2mm drill bit. Attaching the chuck, it says lock the trigger stopper. Push and hold the shaft stopper while attaching drill. Okay, so first you need this. Then you need this. Why is this crooked? This seems like it's too crooked, like it's like not centered, right? So let's see what we did wrong. We may have not centered things properly. Let me get a better screwdriver. Much easier. not centered properly. It's because, nope, everything looks good. Weird. Could be this. Could be that this was not pushed in as much as it should. Okay. Yeah, I think that was it. Okay. Well, double duh. This part here had to go into this part here. That's what was happening. And I think, silly me, I didn't notice that, right? So this white piece should be inside there, not on the other side. I had it before like this. Okay, and that was causing all sorts of drift issues, I'll call it. Drift meaning this whole thing was kind of like shifting over a little bit slightly. So now, when I put it together, yeah, it's looking a lot more centered than it was before. So let's just make sure that I can reattach this properly. There, now it looks a lot more centered. Yeah, so stupid human error. Come on, 3 master's degrees. You can do this. It shouldn't be that hard. One of my master's degrees is in engineering. I know. Kind of ironic, isn't it? So I should be able to repair things pretty easily, right? So when I was younger, I was much better at things, I think. I had more patience. And now that I'm older, it's like I have so much less patience to do things. It's like, let's get it done now, now, now. Yeah. Don't be like that. Try to maintain patience as you get older. Patience is a virtue. Try to make sure that you follow all of the instructions in a meticulous way. There. 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 Very nice. Now, this goes in first. This goes in next. So we got another one here. What's this other one for? Aha, it says one of them is used for 1 to 2 millimeter drill. The other one is used for 2 to 3 millimeter drills. So depending on which one you want to put in, they're for different purposes, different drill bits. So one is smaller than the other one. Let's see. So yeah, we've got a small hole and a big hole one. So let's use this one, the small one first. Let's try this. This goes in here, and this goes in over the whole thing, and then we tighten this, and we should be good. Yes, I should lock it first before I accidentally drill a hole in myself. Huh. Shouldn't the whole mechanism lock? Yes, you have to press this down, I think. There. Then you tighten this, like so. Good. And now, unlock it, and we can drill. Good. Good. Okay. Let's try drilling a hole in something. Let's try drilling a hole in the box. How about that? Easy enough. But anything to drill through paper. Now let's try drilling through, let's say, a carbon piece. No, how about plastic first? Yeah, that's easier, right? So here we go, drilling through plastic. Not so easy. There we go. Okay, so you notice it kind of slid off to the side there. You have to be careful with that. You have to hold this drill in place. So, but it did create this 2 millimeter hole for us. Pretty cool. How about carbon? Let's take a look at carbon. Okay, here's a piece, a scrap piece that I'm going to drill through, or try to. I'm going to try to drill through the J right here. Okay, let me hold this down and move this aside like this, and here we go. Don't have your fingers too close to the drilling mechanism. That could be fatal. Ooh. see what it's done so far, if it's good. So it kind of scratched, nicked at the surface of this. So let's see if we can continue and drill holes. All right, is this any better? Let's see. I do see a deeper divot. It's going to take a long time, I think, to drill right completely through this carbon piece. So let's take a look at this versus this. I wonder if you just simply moved this over to this here. Okay, so I've got this, and I've got this, and I simply moved this here. Would this do the same thing? Let's take a look. Let's drill the 4. So, suffice it to say, I think they actually have the same power. So this and this is like really no different, as far as I can tell right now. They're just using different things to do what they're supposed to do. So actually I didn't have this in all the way. There it is. That's how it should be. There. Now, let's continue drilling. Is it done yet? Nope. It's a little deeper, but not that much. So let's continue. Okay, so preliminary conclusion here is this drill is good for light things like wood, like light wood probably, cardboard, plastic. But for carbon, I don't think this is going to do the trick. I think this is just not strong enough to drill completely through in any sort of reasonably fast way. So you have to like sit there and basically keep drilling, keep holding it in place and drilling. That's not good. That's not really an effective use of your time. Really, you can just buy a simple item such as a Dremel, made by the Dremel company. And I'm going to show you the perfect product for this. If you simply purchased this item here, this Dremel light, it's got this 2mm tip available to it. And, well, maybe it's something I purchased separately, but I'm not sure. But basically, if you just get this, this has enough torque to drill through carbon. So if I just turn this on like so, it's already pretty fast. And I go over here, let's say, and drill into the end, we're going to create a hole. Now, it's so torquey that I have to hold to the piece. And I'm drilling, and I'm drilling, and I'm drilling. Oh, my battery's running out on it, but it's still drilling, still drilling. It's still drilling. Still drilling. Yep, still drilling. And it's through. It's as simple as that. And if we just remove all the carbon dust right there, you'll see there's a hole. There's a hole right there where the end used to be. And I would have to say that the most effective way to drill through carbon is by using this Dremel here. So there you have it. I think don't waste your money on this handy drill. It's not very handy. Instead, get yourself a Dremel light for just a little bit more money than the handy drill. The handy drill is not going to get the job done with carbon. And a lot of you might say, well, it wasn't designed for that. Well, yeah, but when you're looking at all the items that are available, all the tools that are available for Tamiya products, the one thing that you're going to look at is this handy drill, and you're going to wonder if you can really use it to drill holes through carbon, because like that's what most people would honestly want to use it for. We're not going to necessarily want to just drill plastic or cardboard or even thin wood products. We want to try to drill through carbon, and if you don't release a product that enables you to do so in an effective way, then why are you selling it? And why not just tell people, go buy that Dremel. Dremel Light. It does the job. It gets the job done a lot more efficiently and effectively than this handy drill. So that's my build of the handy drill and my assessment of the handy drill. I think it is basically just a carbon copy clone of this, the electric handy router. I think you're just getting a different bit on the end of it with it. So this router, they give you this, well no, you have to actually buy this one. This one creates countersunk holes. And yeah, it does so, but you need to take a lot of time doing it. And what I like to do to speed up the process is I don't drill directly 90 degrees in. I take this and I move this from side to side, angle to angle, and up and down, and then I get back to the center again. And I continue drilling. But the side to side motion helps loosen up the carbon so that I can effectively drill more and more and more out of this hole so they can eventually get a countersunk hole. If you don't do that, you're going to be sitting there for a long, long time. Just like what I did with the drill. You're going to be sitting there for a long, long time trying to concentrate on that one point. And it's not going to get you anywhere. And you'll be very frustrated and you'll hate the tool. So just use the side-by-side motion if you're using a router to try to get countersunk holes in carbon. I know that this is probably not meant for carbon, but you really can use it for carbon if you use my side-by-side up and down approach. And then you can drill countersunk holes through carbon. So everybody, if you like this video, please slam the like button, subscribe to my channel. You'll see more videos just like this one. Until next time, everybody, see you. Bye.